So you want to take a look at nuclear energy, right? So take a look here, right? Take a look here of what it entails, right? So there is this formula, a real popular formula, E is equal to mc squared, that gives us an idea of the energy involved in a reaction, right? We should know in a reaction that we have reactants, and those reactants will produce products. Well, what Einstein discovered is that these masses are not the same, right? There is the mass of the reactants, and there is the mass of the reactants, and there is the mass of the products. These values here are not the same. He recognized that when he subtract this mass of the reactants and mass of the products, he recognized that there was a change, or there was a difference in value, which he called delta M. Right? We call delta MD, this value here, the mass defect. Right? So there's a small change in mass from here to here. Okay? And then he also discovered that if he wanted to find the energy released in these reactions, all he had to do was to take that delta M value and multiply it by the speed of light squared. Okay, C is the speed of light, right? Which is 3 by 10 to the 8 meters per second. Okay, so you have 2 steps. Well, according to how you write it, 4 steps, right? Step number 1, you have to find mass of the reactants. Step number 2, you have to find mass of the products. Okay, step number 3, you have to find the change in mass, which is the reactants minus the products. Subtract both of them, right? And then step number 4, you have to make sure that the mass is in kilograms. Okay? So if delta M is in U, that U is a new unit, it's called atomic mass. You have to multiply by 1.66 by 10 to the minus 27 kilograms. That's okay, right? I'll show you an example that's not. But once this value is in U, you have to multiply that value by 1.66 by 10 to the minus 27 kilograms. And then last step, to find the energy, right? Energy is equal to step 4, which is delta M multiplied by the speed of light squared. And that's it, right? You have these you have these 5 steps, right? Find the mass of the reactants, mass of the products, subtract them, multiply by this to get in kilograms, and then multiply by the speed of light squared. Okay, so I'm going to show you the hardest thing is using the calculator properly, right? Okay, so copy those down, and I'm going to show you how to do this change in mass, right? Okay then, Maria, Sahara. Yeah, so copy down step 1 to 5, right? And I'm going to show you how to do this, right? A calculator, right? Right, in a calculator, I want to learn to use the function x. Well, multiply by 10 to the power, right? Right then. No, I will do that. I think it's like 10 to the power. I think we will use like 10 to the power, right? Right, how do you get come on that? Right, I'm going to finish right online. Check up there, pay attention. Jacob. Nice. Finish. Good. So we're gonna get some practice just using some random values to change in mass. Get some practice, right? Anybody writing online? So what is the word under mass? Oh, defect. Mass defect. Right, so until I finish online, tell me, right? I'm waiting on you. While you're waiting on people online who write it, just do my favor now. Just multiply 0.12 by 1.66 by 10 to the minus 27. Just try that. I want to make sure that everything uses the calculator properly. Right? Multiply 0.12 by 1.66 by 10 to the minus 27. Let's get some practice. I want to see what you get. Let's see. Yeah. There. Right. So you all got this value online? You all got this value here. When you multiply this, you got 1.99 by 10 to the minus 28. Right? Just to make sure that we can do that properly. Yeah, nice. Good. Good job there. Good job, Shannon. You type it in nice. Good. Right? Anybody writing? Good. Anybody writing? Paraj, you got that? Everybody finish right, okay? Everybody finish right? Right. So before we go into our full question, here's what number one is. Number one, I am giving it a change in mass. And I'm telling you that the change in mass is 0.1204 U. Right? No wrong, no. Use the exact values all the time. So I am giving it a change in mass. So ignore step 1, step 2, step 3. Starting from step 4. Okay? I already give it a change in mass. So change in mass is in U. So what do we do? Elena, what are you doing in each here? The value is in atomic. This is a unit for the atoms, right? Mass of the atom. They're a small unit. But we need kilograms. So we have to convert this U value to kilograms. So we're on step 4. So you're multiplying by 1.66 by 10 to the minus 27. That will give us the value in kilograms. Okay? So we have to convert this U value to kilograms. Okay, that's step 4. How much you get? Yeah. Do it from around time. How much you get? Tell me what you got. Shannon got 1.998. No wrong enough, right? By 10 to the minus 20. Somebody else get up? Yeah?
Yeah.
Yeah? Right. So that's step one. We have the change in mass in kilograms. Everybody get our online, Maria? You all got that, Cameron? Okay, you learned your messaging too. Nice one. Nice, good. Step part two now. We have the change in mass, we want to get the energy. Energy is equal to the change in mass by the speed of light squared. We have the change in mass, that's 1.998 by 10 to the minus 28. Right? That's the change in mass. Now we are to multiply by c squared. Right? C squared. So you're multiplying, take your time and sharp, you have a sharp calculator. You put multiply here, then you put 3 by 10 to the 8 all squared. Right? 3 by 10 to the 8 all squared, and you work it out. Right? So take this, multiply it by 3 by 10 to the 8, right? Don't forget to square 10 to the 8, and then tell me what you get. Take your time, check it a few times. That's not. Put the exact number here. What's all you got? Not wrong. Check and tell you. Wait. Yeah, 1.798 by 10 to the minus 11. Not correct one. I feel I put minus 8. I feel I put minus 8 here. That's what the way. Huh? Yeah, now. Right, nice. Ricardo, what's Ricardo? Ricardo there. Right, Barrage, how much you get? Viraj send anything. Viraj. No Viraj. Hi Viraj. What you got? Yeah, it was an example, but you have to multiply it out. I want to make sure you multiply it out. All right. This one is not an example. I want to see your answer, right? All okay with that? Let's go again. Same thing. Same principle, right? I give you the change in mass. So let's get 0.0754. That is in U. 0.0754 U. Try this one here for me. 0.075, right? There's a point there. Right, let me see the answer. Right, your answer should normally be -10, -11, -12, somewhere there, right? Right. Let's check it out and see what we have. Borrowed, check back your power, right? Jacob, I think you leave out something, right? Right, where Viraj? Nice Viraj. Oh wait, Viraj, I'm looking wrong there. I really forget to work it out. Just clear something. Right, I want to do a little video for TikTok, right? So I want somebody who's right nice. Just to write the question, I'm gonna give it a little while. Huh? Yeah. Right? I'll pass it around, watch some people handwriting. You wouldn't be in it. You wouldn't be in it. You wouldn't be in it, right? Huh? No, I just comment here and say neighbor, you stupid all. I'm writing. I just comment here and doing a solution in your book. Right? Or make a correction. All right. Right, Viraj, just check back your work in there. Malini, that looks good. Who am I missing? I have Maria, I have that. Who am I missing? Shannon and send anything. Oh, this young lady name is Shannon. Excuse ma'am. Ma'am. Ishana, ma'am.
Secretarial.
Hi, Ishana. Would I be able to get an answer? Hi, Ishana. Can I get an answer, please? Right, Viraj, just check back your working, right? Unless we're putting the wrong value. Right, let's go again. Let's see what we have. Because sometimes in the recent years, they didn't give you the full equation and thing that they gave it this year. They gave you the change in mass and you have to work it out. Right? So let's see. So E is equal to delta M. Sorry. I want to find the value in kilograms first. So delta M, this value is in U for change in mass. Right? So delta M is equal to 0.0754. That's the value in U. And I'm multiplying by 1.66 by 10 to the minus 27. What you all got?
125.
Is that 1?
5, 10.
Yeah? 1.164. Right, no wrong, no. Huh? Yeah, because there are questions that ask if I put the energy and it's a real small change. But watch how small it changes, we can't put a round up. Right? So you're trying not to round up until down the end. So the energy is equal to delta MC squared. Delta M is this value here, 1.25164 by 10 to the minus 28 by 3 by 10 to the 8 squared. That's okay? And you got 1.126476 by 10 to the minus 11 joules. Here you can round off now and say 1.13, right? By 10 to the minus 11 joules. And our answer is generally around here, right? Minus 11, minus 12, minus.
So you don't have to be this round up.
Oh, no. You don't really have to. Okay, nice. Right. So I think we ready to go into our full question now. Oh, wait, no. Let's see if this thing working. Huh? How about? Any questions online? Any questions online? Cameron, are you okay there? Right. While I'm waiting on the TV to load up there, here's what I wanted to do for me. Right? Here's what I want you to do. I'm going to give you an energy value, and I want you to see if you could just take your time and find delta M. So you're just kind of rearranging the formula, right? So I'm giving you this. I'm going to give you this, and I want you to find this. Okay? So you're just going in reverse. Are you okay with that? Let's take your time, right? While I get this to load, and I will put up a full pass paper for us to try. So here's what you're doing for this one here. Number 3, find delta M if E is equal to let's say 2.11 by 10 to the minus 11 joules. Right? Take your time. Right? Take your time and see if you could do that for me. So you're working in reverse, right? See if you can find delta M for me, but I don't want it in kilograms. Huh? I want the value in U. I want the value in atomic mass. Right, let me just organize this up and post up a little question. Everybody. Because now we're in the game today. All you have video, I think all you have videos playing. I know because she have one. Take a time you're working in reverse. I just want to see what you'll come up with, right? Excuse me, por favor, balik ke debate. Balik ke bar. Barbie. I don't want to sneeze. Right. But that's pass around. I'll do a little tick for the talks. Let's see.
That's not good. Oh, I did something wrong. Big time. What I get here, bro? What the hell, bro?
Same thing. Wait.
This is
Let's find the mass that is equal to
very good. Wait, no. What is that? If we find this one, got it right by the 3 equivalent of this. From the bottom, 85 down by 6, 27. So they get that's a low. And this one big time. Then we divide out of one. What?
Right? Let's see what you all came up with now.
This one.
Anybody have a value? See Malini try something there that looking rightish. Anybody else want to have something?
No.
Try something. Borrow, try something. Come on, please.
Baru. Cuma kita mau baru.
That's all we talk now.
Aksara mana yang baru? Iya. Get two number. Come check this out. Yes. So I get two answers. Tell me which one is going to check on. What's your nonsense? So where you going? Sir, please. Sir, I get.
Right, yeah. So what you have here, the answer looking on the page, what? Remember, you want to get delta F. What you should have also said here was that delta F, which was E, was equal here. You should have also said that you are right. And then what you did here to here.
This by and get that. Right. No, I'm gonna do this. I'm not like this. Why does something like that?
You get enough to please under into TikTok. You know, like how what's something more after what's
Tutorial. That's it. Too long. Yeah, that's
all right, so let's check it out here. Let's see what we got, right? Okay. Yeah, fine. Right. No, I was simple first, but that's what it cost. I was simple. Right. Yeah, well, can do that now. Run on the line. Okay. Okay, nice. So we want to get delta M. So we know delta M is equal to E over C squared, right? So E is 2.11 by 10 to the minus 11. C squared is 3 by 10 to the 8 squared. When you work this out, this value will be in kilograms. How much you got? What you got here? Huh?
2.3.
That's now 2.3. Now I'll stop there. By 10 to the right. That's the value in kilograms, right? Right, I'm writing it volts. All right, 4 volts, right? Right. So when I reach here now, This is the value in kilograms. So what we have to do, we're going upwards. So instead of multiplying, we divide it. Instead of multiplying, we're going to divide. So we're going to divide by 1.66 by 10 to the minus 27. And you got 0.1412. Yeah. Right. Very good, Cameron. Right. So this is your value in atomic mass.
Oh, shit.
Are you okay with that? Yeah.
I just divided.
Yeah. Nice. Copy it down. Copy it down. Let's do one more. Let's make it happy hang and then we can actually let's try pass it.
Yeah.
I'm gonna see this thing link. Any questions online? We have free this message. If you have any questions? Oh, wait, it's shared already. Oh yes, it's shared already.
Can make it pick up the phone?
Yeah, how about TikTok? I don't know. I don't really check in. All right. Right, we only do the reaction part, right?
Oh, I know we are there.
2006 or 7 or something.
Yes, so
2008, Jan 2008.
yeah.
Jan 2008, number 5. Right, so we're starting up here. What I want you to do for my first is to try to write the equation. You're seeing that? Try to write the equation and then we'll talk about the rest, right? Yeah, look the information up there. During a nuclear fission reaction, the uranium isotope is struck by a neutron and splits into a barium krypton and 2 neutron. We'll try to see if we can write the reaction.
Yeah.
Yeah, 23592. Right? So you have to write the reaction. What are the reactants? Uranium and a neutron, and it's producing 2 things there, right? So try that, come on.
Yeah. Five, 2. Somewhere. No.
Any hopes?
No.
None? All right. Let's see how it looks, right? Let's give you a little time to try it there. So here's what they said. They said that the uranium particle, which is 235U 92. You're seeing that? That was hit by a neutron. So you're adding a neutron, 10N. Right? And then it hit the neutron and it produced a barium, Ba, and it produced a krypton, Kr, and 210 neutrons. Right? You had most of that. Very good. Right? So what are the values they gave us of barium? The atomic mass, 144. And the atomic number for krypton, 36. That's all they give us. We have to figure out, sorry? We have to figure out the missing two values. Try that, please. What are the missing two values? Right here, missing a value. Right here, missing a value. Right here, missing a value. Right? Did you remember how to balance equations? We did that week before. Right? For those who don't revise the work, you can listen here. Add up the mass numbers on the reactants. That's supposed to be equal to the mass numbers here. Okay? Add up the atomic numbers here. Supposed to equal to all the atomic numbers down here. Try that, please. See if we can figure out those two circles. 1 is a neutron. Yeah, it's one neutron hit it, and it produced two neutrons.
I told you to put the uranium, barium.
Yeah, you did the neutrons too.
And key R, that's what I mean?
Okay, is it krypton or something?
Like what the ox?
Oh yeah, try balance it quick. Right? Work out the two circle values, right? I'll do it just now. And then we'll go into the calculation. All right, so let's see, I see some values came in there. So this value, how do I work it out? Adding up these two on this side, 235 plus 1. Let's call this value x, right? Then here is 144 plus x plus 2 by 1, right? And we have to solve for x. X is equal to 236 minus 146. Correct? How much is that? 90? 90, okay, good. So the first value is 90. Right, so we're just going back to what we did before in terms of balancing, right? Good job, Jamie. Malini. Right, Malini, good job. Cameron, I think it has forget one thing, right? Good job, Cameron, so far. Here now is 92 plus 0, right? Let's call this value y is equal to y plus 36. So y is equal to 92 minus 36, which is 56. Yeah, so those are two answers. 90, 56. Very good, Malini, Cameron, Jamie. Maria, good. Are you okay with that now? Katrina? You okay with us? All right, so that's what we did the week before, right? Now we have to find the mass, the energy given off in this reaction, right? Copy down quick. And let's go back to the reaction. Grace, you okay with us? Shannon, you still? Anybody writing? Taking it off, right? Why are you going outside, Shannon? Good. So here's what they want now. They want you to work out the energy released in this reaction. So if you look here, I'm going to point out a few things for you. These are your reactants. Okay. These are your products. So of course, you have to find the mass of the reactants, follow the 5 steps, mass of the reactants, mass of the products, and your values right in. Yeah, try that, please. Find the mass of the reactants and mass of the products. Question answered the same way, but I know some of you can't see it, right? What you all notice about the mass here? Right? Look at the mass values, right? Sahara, look at the mass values and tell me what you notice. The mass values are in what? Very good, kilograms, right? It's already in kilograms, so you don't have to do step number 4, right? Step number 4 not necessary because it's already in kilograms. So you're doing step 1, step 2, step 3, and then jump to 5. Okay, try it quickly. Find the mass of the reactants, then the mass of the products. Finish already? Or you can go. Yes, what you have here, you answer the case, what number you want to get delta M. You should have said here was that delta M is equal to E plus C squared. Here, you should have also said that your value in kilograms. Nice. And then what you did to reach here to here. And then you divide. As your force may take long term. I don't know what to do. Take about 6 seconds to do that. right? Basic. Find the mass of the reactants. What are you doing? Yeah. Find the mass of the reactants there, hurry up. Huh? The reactants right there. All right, come, I'll take a look. Right? So our reactants are what? Our reactants are uranium and a neutron, right? So I'm finding step one, I'm finding the mass of the reactants. Right? So where is uranium? Uranium is here. So that's 390.989 by 10 to the minus 27 kilograms. Right? And then we have to add to that a neutron. A neutron is here. Right? A neutron is 1.65 by 10 to the minus 27. How much is that? What's that? $25 kilograms, right? So that's the mass of the reactants. Are you okay with that? Go ahead, find the mass of the products. Let's see what you get. Find the mass of the products there for me. Take your time. I try not to round off until we reach the end, right? Right, so just checking your values here for the products. So the products will be what? Barium, which is 238.893 by 10 to the minus 27. Then we have to add a krypton, 149.241 by 10 to the minus 27. Right? And then you have to add 2 neutrons. So that's 2 by 1.675 by 10 to the minus 27. Okay? So it's 2 neutrons, one barium, and one next one. How much is that? 3.9. 25 kilograms. Nice. What's the next step? Find the change in mass, right? So the change in mass is equal to the mass of the reactants minus the mass of the products. How much you all got there? 1.18 exact by 10 to the minus 27 kilograms. Y'all okay there? Maria, y'all okay there? Raj, follow with me still? Keelan, you follow how we reach up until there? Keelan, follow what we did? Raj, you there still? Raj. You follow up until there, Raj? So what do we do after we have the change in mass, Raj? What do we have? What do we do when we have the change in mass? We reach up until here, the change in mass in kilograms. What to do now? No, it's already in kilograms. Remember I told you leave out step 4? So leave out step 4. Well, what do we do after this now? To get the energy. Because we already have the value in kilograms, right? What's the next step? Right? Good job, Maria. Right, multiply by, right. So you're taking 1.18 by 10 to the minus 27, right? And multiply by 3 by 10 to the 8 squared. That's okay? You already have it in kilograms. So you multiply by 3 by 10 to the 8 squared. How much is that? Josiah, Jesse. What is the first name? Oh, okay. How do you pronounce it? Josiah. I know you have Greece now. Nice, yeah. What you all got? I wasn't listening there. 1.062 by 10 to the minus 10. Right? If you see again minus 24 and minus 42 and vice like that, you know you did something wrong, right? That's okay? You're smiling there, I like physics. Are you okay with that? Right, we can squeeze in one more. Actually, let's just go and answer what they asked us, right? Huh? Yeah, I have a Kahoot for you, but we can't do it now. When you're like, you have enough time. There's a long Kahoot. First thing next week. Next week is the last week, and I'll give you a break, right? Next week we'll round up this topic, and I'll give you a break, and then you have 2 in the holiday, right? 2 classes, and you have, well, 3 if you want, right? 2 in the holidays with online alone, right? I will send you the days and the links. Yeah, no Facebook. Well, I will tell you, it might have space. I'm mixing it with the form files. There's a division on mechanics, thermal, and radioactivity. Right, let us see the parts of this, right? Anybody writing this? No? All right. So let's just see, let us make sure we answered everything. So part 1, we did this already, right? Find the mass of the products, starting products, call the reactants, and then the final products here. We did that already, right? State why the answers are different. Why the answers different? Why is the mass of the reactants and the mass of the products different? Huh? Why are those values different? I told you why. Because, huh? What does the reaction give you? What does this fission reaction give you? Besides that, energy. It gives you energy, right? So that loss in mass, so that change in mass is in the form of the energy, right? Yeah. So the values are not the same because during the reaction, energy is lost. You can probably write it down. Right, the answers are not the same because during the reaction, energy is lost. Energy is given off. Energy is given off. Energy is given off. Right, so the answers are different because energy is given off, right, during the formation of the products. And last part, calculate the energy. And we did that, right? Yeah, because energy is given off as a result of producing the products. And the last part is what? That's what we did, right? Yeah. Anybody could guess what type of energy will appear, or what form the energy will be in? What form do you think this energy will be in? Anybody may make a guess. What type of energy? Or what form, sorry? Huh? Anybody have a guess? Anybody want to have a guess? One little guess. I'm looking for a guess. Shannon, any guess? Sahara, any guess? Right, during this reaction, here's what's happened, right? Yes, we'll talk about fission and fusion next week, right? When the neutron hits this particle, it causes it to split into 2 smaller particles, and it produces 2 neutrons. Those 2 neutrons will hit and next 2 uranium particles, cause it splitting again, and so on and so on, right? What you have here is the reaction in a nuclear power station, in a nuclear reaction, right? So that energy that you worked out there, forgot the value, but that energy is the kinetic energy that the neutrons will have. Okay? So the energy is in the form of kinetic energy, right? So the electrons will take that kinetic energy and create a chain reaction. You'll see what happening here? If you look at this fission reaction, 1 neutron producing 2 neutrons, which hitting the next 2 uranium, which producing 4. Right? So you have that big chain reaction, and 4 will produce 8, and so on and so on. Okay. All right. So next day we'll put this all together. We'll finish up with uses or homework. Write down 4 uses of radioisotopes. 4 uses of radioisotopes. Right? If you do it, you'll qualify for the Kahoot next week. Right?